Hi everyone and welcome to the next lesson of mole and calculations. We are now on lesson 4, which is balancing chemical equations. Our learning intention is to learn the importance of and how to balance chemical equations. So starter questions, we have three questions: potassium sulfate, calcium nitrate and ammonium carbonate, and your task is to write the chemical formula for each of these compounds. So have a wee go and make sure you can do that. Pause the video, attempt the questions, and then if you unpause, I can show you the answers. So number 1 for potassium sulfate, we are going to have K2SO4, your sulfate having a valency of 2. If you go to page 8 of the data booklet, you'll find sulfate has a valency of 2. It's in the 2 column. Potassium has a valency of 1. If you swap and divide down, you end up with K2SO4. Calcium nitrate is a wee bit more complicated. It is calcium with a valency of 2, nitrate with a valency of 1. Again, nitrate ends in 8, so we need to go to page 8 of the data booklet to find the complex ion. When we swap the valencies over, we end up with 1 calcium atom and 2 NO3s. Now, the way we have to do this is we have to put the 2 outside the brackets. Otherwise, we would look like we had NO32. We can't have 32 oxygens bonded to a nitrogen, so we have to show that we have 2 of the whole thing, NO3. That's what the brackets are for, remember. Ammonium carbonate. Ammonium is one of these complex ions that doesn't end in 8, so that's one we have to remember. But again, we have to go to page 8 of the data booklet, find the valencies, swap, divide, and we end up with NH4 in brackets 2, and then CO3 for carbonate. Writing chemical formula is really important because if we can't write chemical formula, then it's going to be difficult to balance equations if we don't get the formulas right. So what we're going to do is we're going to learn how to balance chemical equations by practicing lots of different examples. And what we want to be able to do at the end is balance any chemical equation that we are given. So first of all, why are we doing this? What goes into a chemical reaction must come out. Atoms don't just disappear or just appear out of nowhere. Whatever you start with, you also have to end with. So that's why the equation must be balanced. The number of atoms on the left, or the reactant atoms, must equal the number of atoms on the right, or the product atoms. Each number must equal that of the other side. So, first example, we're going to look at each element individually. Here is our equation. We have CH4, which is methane. This is a combustion reaction, reacting with oxygen, O2, to give carbon dioxide and water. We have to balance our carbons, then our hydrogens, and finally our oxygens. So it's really helpful to write CHO in the middle, CHO. Carbons on the left, we have 1 carbon on the left. Hydrogens on the left, we have 4. And oxygens on the left, we have 2. That's where those numbers come from. We have 1 C, 4 H's, and 2 O's on the left. How many do we have on the right? We have 1 C, 2 H's, and 3 O's on the right-hand side. What we want to be able to do is to make these numbers the same on both sides. Now that's going to involve multiplying the whole compound by a big number, we say. So our carbons on each side are 1, they are balanced, so we give them a nice tick. The hydrogens, however, are not balanced. We have 2 on the right-hand side and 4 on the left. So it's as simple as, how do we turn a 2 into a 4? We have to multiply it by 2. Now, we can also add 2 in maths, but in chemistry, we can't. Remember, atoms can't just be added in. We can multiply them, we can add them. So to get from 2 to 4, we have to multiply by 2. Now, we can't change the formula of water. We can't say, all right, we'll just make it H4O, because that doesn't exist. Hydrogen can't make 4 bonds with oxygen. H2O is what the compound looks like. We can only multiply the whole compound. We can't change its formula. So how we do that is we put a big 2 or a big number in the front of our compound. So that now means that we have 2 times 2 hydrogens, which is 4, but also we're going to have to change our oxygens, because rather than have 3 oxygens on the right hand side, we now have 4. We have the 2 in the CO2 and the 2 in the H2O. Okay, so make sure that as you change things, you're still counting all the atoms and making sure that you have the right numbers on both sides. So now we have our balanced carbons, our balanced hydrogens. Lastly, we need to balance our oxygens. On the right hand side, we now have 4, and on the left we have 2. So just like we did last time, we are going to multiply this whole compound, or the whole molecule O2, by a number 2. There it's there. Now we have 4 and our oxygens are balanced. Now it is as simple as that, using big numbers to multiply out our atoms and make sure we have the exact same number of each atom on both sides. Here is the finished equation with all our big numbers in it, and that's us done. Our next example is another combustion reaction, so we're reacting a compound with oxygen. This time we have propane. So we have C3H8 plus O2 gives CO2 and H2O. Let's write our CHO again, our carbons, hydrogens and oxygens, and let's count the numbers of each atom we have on both sides of the equation. We have 3 carbons on the left and 1 on the right hand side, 8 hydrogens this time on the left and 2 on the right hand side, and 2 oxygens on the left and 3 on the right. So let's start again as we always do it with our carbons. We have 3 on the left and 1 on the right. How do we turn a 1 into a 3? We multiply by 3. So our whole CO2 compound is going to be multiplied by 3. That means that our carbons are now balanced, but we have knocked out our oxygens. We used to have 3, now we have 3 times 2, which is 6 from the CO2, and we have 1 in the H2O, which is 7 in total. So remember, every time you add a big number to a compound, you have to go through each atom and make sure that you change the number to the number that you have. So rather than having 3, we now have 7 oxygens on the right. Hydrogens this time, we have 8 on the left and 2 on the right. How do we turn a 2 into an 8? We multiply by 4. So when we do that, we end up with 4 times 2 hydrogens, which is 8. But again, we have 4 times oxygen. So we have 4 oxygens plus the 6 from CO2, from 3 CO2s. So our oxygen number is now 10. Like I said, it's very important every time you put a big number in front of a compound to double check all of the atom numbers. Now we have 10 oxygens on the right and only 2 on the left. So our balancing number for our oxygens is going to have to be a big 5. So if we put a 5 there, 5 times 2 is 10. We now have 10 oxygens on the left and our equation is balanced. Now again, for good practice, write your fully balanced equation out with all of your big numbers in it at the end. Task 1, there are 6 examples for you to try. So I'd like you to try these, and then once you're finished, pick back up here in the video and check your answers. So give yourself 1 mark if you get the whole balanced equation correct. So you should have a mark out of 6 for the total for this task. Pause the video now, attempt the task, and then unpause and you will see the answers. Here are the answers for task 1. Have a look over your answers, make sure that they are matching. If they are, very well done. If they're not, don't worry, as long as you know where you've gone wrong, that's fine. If you're unable to see where you've gone wrong in your equation, then put a wee star next to it and ask your teacher next time you're in class, and they'll be able to help you. So we wanted to know if we could balance chemical equations for unknown reactions. Here is an exit task which has come straight from a past paper question. which is balancing equations with some problem solving added in. So it looks quite difficult, but once you know how to do these questions, they do become more straightforward. So what I'd like you to do, again, pause the video, have a wee go at this question, get an answer, and then unpause, and I'm going to talk you through how to get the answer. So we have XH2O2 turning into YH2O plus ZO2. And the question says, this equation will be balanced when, and you have 4 options. Now, from these 4 options, it's easy to see that X can either equal 1 or 2. No other number can go in there because there's no other options. Those are the only options we are presented with. So what the strategy is that I use for this question is just simply plug in the numbers and see if it balances. So let's start with the situation where X equals 1. If X equals 1, then we are going to have 2 hydrogens and 2 oxygens on the left, okay? Where X equals 1, that means we'd have to have 2 hydrogens on this side, so Y would need to be equal to 1. But if Z equals 1, we would have 3 hydrogens on the right. So that doesn't balance with the 2 on the left. So that from that we can deduce that A and B cannot be the correct answer. Because if X is 1, we end up with 3 oxygens on the right hand side and only 2 on the left, which doesn't balance. So A and B are immediately cancelled out as not possible to be answers. C and D this time have an X value of 2. So if we put 2 in this time, then we have 4 hydrogens and 4 oxygens on the left, because we'd have 2 times 2 hydrogens and 2 times 2 oxygens. That would mean that Y would also have to be 2, because if we have 4 hydrogens on the left, we have to have 4 hydrogens on the right. So that means if X is 2, Y needs to be 2 as well, which both C and D are. So let's check what Z needs to be. If we have 2, Y equals 2, then we have 2 oxygens on the right hand side, and we need 4 because we have 4 on the left. So that would mean that Z would also need to be 1. So we'd have X equals 2, Y equals 2, and Z equals 1, because 1 times 2 oxygens is 2, plus the 2 from Y is 4. So your answer for this question is going to be C. X equals 2, Y equals 2, and Z equals 1. Now, when you look at that to start with, because there's X's and Y's and Z's, it can be a bit confusing. But hopefully I've given you a strategy that you can use to figure out these questions. This is taken from a past paper question from a National 5 exam. So you are going to be faced with challenging questions like this. It's very important that you try and practice lots of different strategies for figuring these types of problem solving questions out. Well done if you got that. Excellent work. And that is the end of lesson 4, balancing equations. Thank you for watching.